Have you ever stopped to think about what's really running everything behind the scenes? All the big stuff, the global financial markets, the video games you love. A huge chunk of it is built on this one language that's kind of invisible, but it's absolutely everywhere. So let's get into it. This is the story of C++, the invisible titan of programming. Okay, so to really get why C++ even exists, you gotta rewind the clock to the late 1970s. Back then, programmers were facing this huge trade-off. It was like you had to pick a side. Did you want something super fast and powerful, something that let you get right down to the metal? Or did you want a language that was simple, elegant, that made it easy to build complex things without tying your brain in knots? The thing is, you couldn't really get both in one package. And look, this wasn't some academic debate, right? This was a real-world headache for programmers every single day. And it's that exact dilemma, that frustration, that lit the fuse for what would become C++. So picture this. It's 1979, and a programmer at Bell Labs, Bjarne Stroustrup, is right in the middle of this mess. He's working on this super complex project, and he's totally stuck between a rock and a hard place. On one hand, he's using a language called Simula. He loves it. It's so elegant, lets him organize his code in these really clean, high-level ways. But for the kind of systems work he was doing, man, it was just way too slow. And then on the other hand, you've got C. C is a beast. It's ridiculously fast, super efficient. But it just didn't have those nice features for handling big, complicated programs. What he really needed was the best of both worlds, the elegance of Simula with the raw speed of C. So what do, right? The tool you need, it just doesn't exist. Well, if you're Bjorn Stroustrup, you don't just pick the lesser of two evils. Nope. You build it yourself. And that single decision, well, that's what kicked off the birth of a brand new language. But here's the clever part. He didn't start from a blank page. His big idea was to take C, which, was already the undisputed king of performance, and just bolt on the good stuff from Simula. Those powerful, high-level features, he wanted to build them right on top of C's foundation. His first name for it was pretty literal. C with classes. And the goal, right from the get-go, was super clear. It was all about creating a language where you didn't have to make that awful choice between power and elegance anymore. The whole point was to give programmers that raw, low-level control when they needed it, but also give them these powerful, high-level tools, these lightweight abstractions that wouldn't bog everything down. And that idea, it wasn't just for the first version. It became the absolute core philosophy of C++. It's North Star, really. For the next, 40 years, pretty much every new feature, every decision made about the language was held up against that one standard. Does this help create abstractions that are both elegant and efficient? I mean, Stroustrup himself puts it best. C++ is a language for developing and using elegant and efficient abstractions. See, it's not just about cramming in more features. It's about giving developers the tools to build their own tools, to create these really clean, well-defined concepts right inside the code, leading to software that's just better, cleaner, and faster. Okay, but here's the million-dollar question. How do you add all this cool, powerful stuff without slowing the whole language down? Well, the answer is something called the zero overhead principle. This is like a foundational rule in C++, and it's super simple. What you don't use, you don't pay for. It means if there's some fancy feature in the language and you decide not to use it in your code, it costs you nothing. No performance hit, zilch. That's how C++ manages to stay just as fast as C when you need that raw speed. There's this classic saying in computer science from David J. Wheeler that just perfectly captures the essence of abstraction. It goes, all problems in computer science can be solved by another level of indirection. Except for the problem of too many layers of indirection. And that little add-on, that is the C++ philosophy in a nutshell. It's all about using the power of abstraction, but being smart about it. Because it knows that piling on layer after layer can absolutely destroy your performance. C++ is designed to give you just the right tool for the job, without all that extra weight. But look, C++ wasn't just created in '79 and then frozen in time. Not at all. A huge piece of its story, maybe the most important piece, is that it's a living language. It's constantly evolving, constantly adapting to new problems, new ideas, new hardware. And that journey from, one guy's personal project to a global standard, that took a while. It starts in '79 as C with classes. Then, in 1985, you get the first commercial version. A really big deal was in 1998, when it became an official ISO standard. But the next huge leap forward, that happened in 2011. Yeah, the 2011 standard, what everyone calls C++11, was a total game changer. It was so massive that Strustrup himself said it made C++ feel like a new language. And why? Because it suddenly allowed programmers to write code that was way clearer, way simpler, and more direct. And get this, it often made their programs run even faster. It was a huge win-win. All right, so that brings us to today. With all these shiny new languages popping up all the time, why on earth does a 40-plus-year-old language like C++ still matter so much?
Well, it's because that original mission, that perfect blend of raw power and smart abstraction, is more important now than it's ever been. C++ is the engine room of our digital world. It's running the high-frequency trading systems on Wall Street. It's the powerhouse behind the graphics in AAA video games. It's taking away inside cars, medical devices, you name it. Basically, anytime performance is an absolute, non-negotiable requirement, C++ is still the go-to answer.
Like Stroustrup says, C++ is a language for someone who takes the task of programming seriously. This is the tool you reach for when you're building the heavy-duty, high-stakes stuff. It gives you the ultimate control to manage every single resource, to account for every byte, and to wring every last drop of performance out of the hardware. I mean, our whole world runs on quality software, and C++ was built from the ground up to deliver exactly that. So, I'll leave you with this final thought. We're in an era now where a lot of the newer languages are all about simplicity and making things as easy as possible. And that's great. It's perfect for a ton of different jobs. But it really makes you think, doesn't it? In a world that's always adding more and more layers of abstraction, where does that leave us? When is that raw, direct, ultimate control over the machine? When is that not just a nice to have, but an absolute critical necessity?